Hello, everyone. Today, I want to take a look at the fundamentals of solving linear equations. Explain what that means and talk about how to solve it. So our goals for this, what you want to get out of this, is be able to solve linear equations in one variable, and then be able to clear denominators or get rid of denominators from equations. So first off, let's start over here on the left. What a linear equation is. Let's just read this. It says a linear equation is an equation in which the variables could be more than one, but they would look at equations with one variable mainly, are only raised to the first power. Okay, so anytime if it's a linear equation, anytime you have a variable, it's only raised the first power, no other power. Okay, so it says no variables are multiplied or divided by each other, no variables denominator, no x squared or square root of x or anything like that, or cube root or e to the x, anything like that. Okay, now one example of a linear equation in one variable can be written like this. It says a and b are constants. Let's come over to the right. So an example or examples, I guess I can say, is we can have, so 2x plus 1 is equal to 7. That's a linear equation. And also, like in this form, you'd have maybe, 4x minus 3 is equal to 0. Okay. So those are examples of linear equations. So once again, in this case, a linear equation is in one variable. Okay. So where we have an x or a y, whatever. In fact, this actually changes. Let's make this a y because it doesn't always have to be x. So your variable, whatever it is, no matter how many we have. Okay, in fact, let's do, as always, the first power. Let's even do one more. 2x minus 3y is equal to 1. Okay, that's still a linear equation, this time in two variables. The main thing being linear is that every time you see a variable, it's only to the first power. Okay, now, so that's what we mean by linear. Now, if it's not linear, there are other ways to solve those, but today we're just talking about how to solve linear equations with one variable. So let's take a look at how to do that. Let's go back over here to the left. So to solve these equations, we solve linear equations in one variable. The basic rules for solving any equation says you can add or subtract the same number, any number, to both sides of an equation. That's a general rule. You can add or subtract any number to both sides of an equation. Okay. Now, rule number 2, you can multiply or divide any non-zero number by both sides of an equation. Okay. Now, the reason why it says non-zero is, of course, you can't divide by 0. You know that. That'd make it undefined. The reason you can't multiply both sides by 0 is nothing wrong with that. But then you end up with 0 equals 0, which is true, but not useful. Okay. Well, let's take a look at some examples to solve. So our direction is just to be that, to solve. Look at our first one, number 1. Let's say we want to solve 2x minus 3 is equal to 8. And for most of you, this is going to be a basic review. So our goal then is to get the x, or the variable, whatever it is, by itself. Okay, so get it by itself. So first thing we need to do is actually get rid of the 3. So we get rid of that. Remember, if it's having minus 3, the opposite of that is plus, so add 3 to both sides. And you don't always have to write this out like this all the time. Sometimes it can help. Of course, now this would cancel out. You'd have 2x is equal to 11. Okay, and our goal is to leave the x by itself. So the problem here, what's in the way is the 2. So get rid of the 2 is divide both sides by 2. That crosses out, and we get x is equal to 11. Okay. Now, if you want to check your answer, we won't do this, we won't demonstrate this except now, but if you want to check to make sure that's correct, and of course, just plug in x equals 11. All right, so up in our original equation, so 2 times 11 minus 3, well, sorry, 11 over 2. I'm sorry, 11 over 2. Wow, be really careful. Okay, 11 over 2. Like, let me make that better. Minus 3 is equal to 8. Let's see if this is a true statement. Okay. So here, the 2's will cancel out. We're multiplying 2 by its 2 over 2. And so you have 11 minus 3 is equal to 8. And right, that is 8 equals 8. Check. So that's true. So if you're ever unsure if a variable is actually, if your solution is right, or kind of look back through your steps, you always plug it back in, make sure it's correct. Okay. Number 2. Number 2, let's say I have this. 3y minus 4 is equal to 8y minus 19. Okay, now this time we have the y variable on both sides. And it doesn't matter which side ends up on. Once you still want to get x by itself, the same thing. Or get the y by itself, since it's a y this time by an x. And let's just choose, let's say just get y on the left. Once again, that's a choice. Okay, also having some error kind of flashing in my video, but just ignore that if you need to. It's not important. Okay, so if I want to get on the left, then what I can do is, well, first off, so I want everything else to the right. And so kind of I did in the first example, let's add 4 to both sides. And so that's going to give me 3y is equal to 8y minus 15. Okay, combining those. Now, let's talk about the variables. So one of the variables on the left, so then essentially the only way to move this in a sense is to subtract it since it's added. So minus 8y from both sides. That cancels out. Combine these, it leaves us with negative 5y is equal to negative 15. Okay, and then one's going to get y by itself, so divide both sides by negative 5. That cancels out. Y, of course, a negative by a negative is a positive, and that's going to be positive 3. Once again, if you want to check it, make sure it's right, plug it back in. Now, let me also say this. If you want, you can also get the y on the right side. And I encourage you to try that on your own. Get the y on the right side instead and see that you get the exact same answer. Okay, number 3. Now, number 3 is going to look a little bit different, and we'll see we need to do a couple things first. So let's take a look at this one. Number 3, we have on the left side, negative 3 times in parentheses, 4 minus x is equal to 5 minus x minus 1. Okay. Now, what's different about this one? Well, if you notice, we have these parentheses. We need to, so before we start adding, subtracting things from both sides, we need to kind of simplify each side first. That's what we're going to do. So we're going to simplify each side first to kind of make it look more like one of the first two. Maybe look like maybe number 1 or maybe number 2. Okay, we want to make it look like one of those. We can't, but it doesn't look like that yet. So the way to get that is to simplify each side first. And to do that, we're going to use like an M. Use order of operations. Hopefully you remember order of operations. If you don't, basically what it means is that it's a consistent order of way to do everything. And this is the way, it's basically, it's to some extent a choice, but to make sure we all make the same choice for how to do things. Okay, for example, this is the order your calculator uses. Okay, so remember order of operations, I didn't write it down, but just kind of review it in our minds. Order of operations, what it says is that you do things in parentheses or grouping symbols first. So you can simplify anything inside those first. Next, simplify exponential expressions, if you have those. Then the next step is do multiplication or division in order from left to right. So whichever comes first in order from left to right. And then finally, last but not least, do addition and subtraction in order from left to right. Okay, so let's take a look at this one. Now, start with the parentheses. In this case, there's nothing I can do inside the parentheses. Okay, so I'll leave those inside the parentheses as they are. Next, there are no exponential expressions. So next, I multiply in order from left to right. So here, what I want to do on the left side is distribute that -3. That's going to become -12. -3 times -x is plus 3x equal to, then on this side, I'm going to distribute the -1. So I have 5, and that's become minus x. And then negative times -1 is plus 1. Okay. Now, still keep simplifying. This side is still simplified. I can't combine these, but I can combine these constants on the right-hand side. And so if I do that, the left-hand side is still the same as -12 plus 3x. And over here, I'll have -x, then plus 6. Or I can write it as 6 minus x. It's up to you. Okay. Now this looks a lot like number 2, the second one we did. Okay. Now, once again, doesn't matter which side I get things on. In fact, this time I think I'll put, I think I'll just say for a change, so get x on the right. Once again, it's entirely up to you. So if I want to get x on the right, I need to move, is that what I did last time? Now, last time I got the variable on the left. Yeah, let's get it on the right this time. This doesn't matter. Okay. And this time I'm also going to show you something you can do. You can combine both these steps at the same time. So if I want to get the variable on the right, I need to subtract 6 from both sides. Then I also need to move the x term over here. So I also need to subtract 3x from both sides. Okay, so I can do these in one step if you want. That's up to you. Just to make sure you can understand it, you do that. So here, these cancel out. And over here, these cancel out. So what I'm left with then is, on this side, that's going to be -18. And on this side, it's going to be -4x. Okay. And, of course, get the x by itself, divide both sides by -4. Let me also just turn this around. I can do that. So the -4s are canceled out. I have basically positive 18 over 4. And if you notice, that's also will reduce. You divide both sides by 2. And that's going to be 9 halves. Okay, so that's our solution. So as you see, this is the general rules. And in fact, we'll see later on an example where I actually want to do something else first. But generally, if you have something like this before, you can start adding, subtracting the same thing on both sides. You need to simplify each side and make it look more like an equation we've already seen. Okay. Now, moving on. Now let's take a look at the next idea. So here we're going to solve equations with denominators. We're going to solve equations with denominators. Okay, so let's talk about how to do that, or how to clear denominators from equation. You can also say that way to get rid of them. So let's look back up to the left. First off, let's go and write down our first example and kind of see what kind of an equation we're talking about. Let's just start by numbering over again. Start with number 1. And let's say I have m divided by 3 minus 4 is equal to 2/3. Okay. Now, still have the same goal. Still want to get the m by itself. Now, you could also work with fractions, but that can also be often be a pain. So often what's easier to do is we can get rid of the denominators or clear the denominators. Okay, and how to clear the denominators. Let's take a look over here to the left and see how that works. So it says to clear the denominators from an equation, find the least common denominator or any common denominator. Okay, actually any common denominator would work. So the advantages of the least common denominator, which is going to be the simplest thing. Okay, but any common denominator will work. But if you don't use the least common denominator, often you'll have to simplify afterwards. Okay, so what's our least common denominator, or LCD? If you try to find the LCD, it's the smallest thing all your denominators will divide into evenly. In this case, of both 3, that makes it simple, 3. Now, I found that. And also another common denominator would work. We would do 6 or 9, that would also work. But that would then, you probably have to simplify more at the end. So now, what we want to do now is just multiply both sides of the equation by this number. It's the same rule we had before, which you do to one side of the equation, you have to do the other side. Okay, so if we do that, then that's going to be 3 times m over 3 minus 4 on this side, and then 3 times 2/3 over here. Okay, let's start with this side. It's probably easier to work with. Can't cancel these out. Just remember this is going to be 3 over 1. So I multiply that across, be 6 over 3, which will reduce, but these cancel out, and I'm left with 2. Okay. Now here, distribute the 3, and I'll write this step out. So 3 times m over 3, then minus 3 times 4. If I simplify that, the 3's cancel each other out here. So we have m, and here 3 times 4 is 12, and minus 12 is equal to 2. Now, if you do this correctly, you should be left with an equation with no denominators. And that's what we have. Okay. Now, this time, I'm not going to write out what I'm subtracting. As you do this more and more, you'll be able to do that easily. And so here, we're going to add 12 to both sides. So then m is going to be 14. And that's our solution. And once again, of course, if you plug that in, you want to do that, try that on your own, check it. You'll see that works. Let's do one more of those. Make sure we got the hang of it. And actually, let me double check, make sure that's the one I want. Okay, yeah. All right. This time we have x over 4 minus x over 3 is equal to, let's make that 1/5. Okay, now here, this is one a little bit different. Of course, this time we have 2 variables. Now here we're going to kind of change our general rule we said a minute ago. So remember earlier, let's go back and take a look at that equation. We said you want to simplify each side first, generally. Okay, this one, before you do anything else. And you could do that here as well. But this one is actually easier, so we could actually combine these on this side. But I think it's going to be easier if we get rid of the denominators first. And that's perfectly fine. So let's do that. So this is one of those cases where, particular cases where it'd be easier to actually get rid of the denominators first. Okay, so once again, let's clear our denominators. And if we clear our denominators, so we need to find our least common denominator. Okay, now here we're not really going through the process how to do that, but if you did, it turned out to be actually going to be 60. Okay, and essentially you have 4 and 4 and 3. There's going to be the smallest thing, they all divided to even. So it turned out to be 60. And if you have trouble finding least common denominator like that, then that's something you probably need to there are other resources to look for. You can do that, learn how to do that. Okay, and also in this case, particular case, that's the same thing we get if we actually multiplied our denominators together. So you can always get a common denominator by just multiplying your denominators together. It may not be the least common denominator. It is in this case, won't always be true. But sometimes that may be easier than trying to go through the process of finding the LCD. So if you have trouble finding the LCD, simply multiply all your denominators together. That will always work. You just may have to do more simplification at the end. Okay, so multiply everything by this. So 60 times this side, x over 4 minus x over 3. And then 60 times 1/5. And then, as we did in the last example, simplify. So 60 over 1/5, 5 would go into 60 12 times. And so this side is going to be 12. Here, distribute the 60. I'll write this step out. 60 times x over 4 minus 60 times x over 3. In a similar way here, 4 will go into 60. Remember, this should always go into it because it's a common denominator. 4 will go into 60 15 times, and 3 will go into 60 20 times. Okay, and so that's going to be 15x minus 20x is equal to 12. Now we have an equation with no denominators, which is what we wanted. Now we can also simplify everything on this side more easily. Okay, combine those, it's going to be negative 5x is equal to 12. And of course, now just divide both sides by negative 5. So finally, x is equal to negative 12 fifths, and that does not reduce. Okay, so that's how you clear or get rid of denominators. Now let's do one more problem. This is going to be a little bit different. What we're going to do is, this is another linear equation, as we'll see. We want to solve this equation, 7x plus 3y equals 1 for y. Okay, what does that mean? Well, first off, let's review this is a linear equation. Okay, we have two variables, as mentioned before, they're both to the first power. So this is a linear equation. Okay, what it means is solve for x is, or solve for y rather, it's the same thing we did before. So now we want to get the y by itself. Okay, actually, let me check something up here. Okay, just want to check something real quickly. Get the y by itself, and it's the same concept. Okay, if I want to get the y by itself, I need to move this to the other side. So the way to do that is subtract it for both sides. So subtract 7x on both sides. Now we have 3y is equal to, right, is either 1 minus 7x or negative 7x plus 1. That's up to you. Okay. Now, once again, still get the x by itself the same way I did in the other equations. So divide both sides by 3. And of course, the 3's here cancel out. I have y is equal to, and I can leave it like this, 1 minus 7x over 3. Or, remember, I can break those up into two fractions. So we say or, because it's the same result, just a different way. 1/3 minus 7/3 x. And this is useful because this is the equation. They're both equations of a line. This, basically, if you graph this, this makes a straight line. But this is based on what's called slope-intercept form. That's something that you may have heard before and probably have. Okay, so that is our review of solving equations, linear equations. So remember, our goals were to solve linear equations in one variable, and to clear denominators from equations would be both those things. Okay, so as usual, if you have any questions, let me know. Otherwise, have a good day.